Right. Are we live? Hello? Is this thing on? Yes. Let's have another go at doing some Voron live stream of firmware configuration. So last time things didn't go quite well, and we'll explain that in just a minute when things kick off kind of more properly. We'll wait for actually 7:30 to appear, and then we'll get started. I'm not seeing any activity in chat. Here we go. Oh, is it doing like super long latency? No. Hey-oh! Everybody say hey-oh! Boom, boom, boom. Today we're doing like sauna edition live stream, because if you haven't heard, the temperatures here are ridiculous. Well, for us anyway, us poorly equipped Brits with no air conditioning or any real means of keeping cool. So I have a fan pointing at me almost the entire time, just to try and keep at a reasonable temperature. So, first things first, we're sponsored today kind of by LDO Motors, OneTwo3D and BigTreeTech, because they provided parts for this build, just so you know. We're also doing a giveaway. By we, I mean me. So we did a giveaway in the first time we attempted this live stream. At least we tried to. Things didn't go quite well. We'll get to that in a minute. And so I kind of cancelled it. But all of those entries that were in that one will still be valid today. So if you entered in the last stream that is now private and you can't see because everything just went poorly, then you don't need to worry about entering again. For those that do still want to enter, we can enter. The giveaway is going to be a bit different because we have new things. So this is the link to enter. That should work fine, and that'll stay pinned for the whole time. In terms of what we're giving away, so before I think, oh, don't need this, but I might need it in a minute. I've got some notes about the issues we've had. So these are the Daybreak LEDs. So first we had this one, but in white. This is obviously just white LEDs, but now on a black PCB, so we're giving away one of these. This is the same as that, but shorter. So this is like 170 millimeters long. It should be good for, well, it goes like in the side of a Voron. It won't go across the front on the top hat because that's a little narrower. That needs something like 150 mil. But for down the side, which I think is the best place to put it anyway, you got this. And then we've got two new ones, which are RGB versions. So exactly the same sizes, but with, well, the LEDs are not the same size, but the PCB is the same length, and these are NeoPixel compatible. So you've got this 3-pin connector, and you can put them in a chain, do all this kind of stuff, and they're all addressable kind of thing. So you have the full length one, and you have a short length one. So in total, 4 different designs, and we'll give away how should we do it? We could give away like a pair like this and a pair like this, or a pair of short ones and a pair of long ones, or we could do like 4 separate giveaways of individual ones. I don't know how's best to arrange these. These are like the quality reaches, some of these. The success rate on the long RGB ones has not been ideal, but I have tested every single PCB that goes out, so I know that they all work, so you don't have to worry about that. You can find them on the Vector3D website. What is going to be the giveaway? I need to decide. We'll do 2 draws. We'll do a draw for white and a draw for RGB. So you get, you either get this and this together in a package, or you get this and this. So we'll draw one pair, then the other. You can't win both. Same kind of rules apply as normal. So there you go. That's that. happy to finally have them available though. Now, let's talk about this because things are a little bit different to what they were before. So I'm going to use a pointy stick for pointing at things. So you'll notice here that we now have an LRS 200 power supply instead of the 2 power supplies we had before. So those 2 power supplies were these two, UHP 248 and a UHP 224. So the 24 is the one that was producing weird crackly noises when turning it on, which was obviously not good. A little bit further testing it indicates that it is indeed not good at all. So that is definitely out. Something sharp on the table. So yeah, that had to go, and I put in a different power supply, which is this LRS 200 24 volt power supply. And then for the 48 volt one, I tried using this LRS 200 24 and that 48 volt power supply, and it did weird things. Like stuff just didn't really work for some reason. I'm not exactly sure why. Nothing particularly broke, but weird stuff started happening. Like Wi-Fi was dropping out, power was going weird. So I think I don't know, somewhere about the motor power control board thing just wasn't working quite right. And there's not really space for it now either. So that left as well. The next change you might have noticed is I now have an Ethernet cable coming out the back. Upon further testing, I identified that when you plug in this BigTreeTech Pi TFT50 to your Raspberry Pi, whether it's far away, nice and close, tiny cable, long cable, in the chassis, out the chassis, whatever you do, it seems to just break the Wi-Fi. I don't know, it's probably something to do with the power draw of this screen, but even if it's on like 0 brightness or whatever, or maximum brightness, seems to make no difference. It seems to just destroy any chance of the Wi-Fi working. No idea really, like technically why, but it does. So now I've just used a Ethernet cable out the back through a little keystone thing, which is kind of how it's intended to be used, and that's straight to that Ethernet cable, which gets me a much more stable wired internet connection, network connection anyway, so that's okay. The next thing is micro USB cables are generally shit. Excuse my French. They're made with such tiny thin cables that the voltage drop even on like a 20 centimeter cable at reasonable powers is atrocious. So what I tested with this power supply, which is a 5 volt, 5 amp RS quality, like this is a decent power supply for 5 volts, 5 amps. And the old micro USB cable I had could not supply sufficient power to the Pi and the screen. I did the same test, but with the official Raspberry Pi power supply, which is like 5 volts and like 2.5 amps, so less potential current in theory, but with an 18 gauge power for the micro USB cable, which is what they have on their official power supplies. And that was able to do it fine, which means this power supply was not the problem. The problem was the amount of current that could carry in the cable for some reason. Even though it didn't get hot, it was just rubbish. So I took that micro USB cable out and cut up another one, which luckily happened to be slightly thicker in the copper, so that voltage drop seems to be lower. We now don't have problems. We can power it seemingly okay. We've got all the devices plugged in, so we've got communication to here, and the USB power up to the camera. Well, that's the power and the data actually. So that's all of that, and I think that's pretty much all the changes. Obviously now that our motor power is the same as the input power, we probably don't actually need these wires. I don't think they're going to do anything. But anyway, the motor power for all the drivers is now going to all be 24 volts, which is a bit of a shame because the point of getting the 5160s is that we drive them off 48 volts. I think they will work okay with 24. It just will not be quite as great as it was going to be. Oh, don't even get me started. Yes, you can technically use GPIO for power, but basically I had that initially and it killed the Raspberry Pi, but this one is now dead. Whether it was to do with that GPIO connection or the power supply being shit, a combination of the two, the lack of protection on the GPIO or something like that, I don't know what killed it, but you get much better protection if you power via the USB input. So we're going USB input with a separate power supply. This is dead because of that. I have a question about your divider PCB. Okay, not exactly the greatest time to ask, but is there a certain wattage that you run for the bed, or is it optional, like you can run an Ender 3 bed? I can't remember what power an Ender 3 bed is. The rated currents and stuff are in the documentation. I don't think, is the documentation available? I think the documentation's on the GitHub, isn't it? Anyway. Yes, all the daylight PCBs, now that we had the RGB ones in the last few days, all those deliveries went out today. Oh my God, my hair's dry already. I made my hair nice and wet to try and cool me down, and it didn't work. Well, it worked for a bit, and now my hair's dry anyway. So the plan today, you can see it's all powered on now. It is actually working, which is great. Although, I know it is working. Okay, so I know it's just been a lot of talking so far, but we have things to cover because of what happened. So where are we at the moment? Basically, I've started some of the configuration, but it's not finished. So I've done kind of the easy bits, I guess, that you probably will have seen 100 times before. So what I've done so far is I used the Raspberry Pi imager. You probably have seen it before. Let me just show you quickly. This tool, I'm sure you've seen it 100 times, where you go in here, you tick this, for 3D printing, you go to main cell, and this is your thing, and you do that, and you flash that to your SD card. So that's all done. You then insert the SD card into the Raspberry Pi and do all the updates. You press check for updates, all the things run and check, and I actually use that as a method for stress testing. Interestingly, works quite well. And I've got all those updates. They should be all done if we can find those too. Back over here. Here you go, update manager. So you press here, check for updates, and it checks all these things. We can do it again now, but unless there's been an update since this afternoon, we should all be good to go. So that's all that. So once we've got all the updates, I've also installed Klipper screen. So if I can flip this around a bit, you should see on here, on the screen, whoopsie-daisy. I have installed Klipper screen, so the screen is working, which is good. I mean, obviously, like the Klippery functionality doesn't work yet because we've not actually configured Klipper, but the screen itself is working, and I haven't taken the Peely thing off either. But basically, it's in and it's functional. Oh, look, there's a Klipper screen update. Oh, I think maybe I hadn't restarted it since I did that. Okay, we can do that now probably. Hopefully this is not going to take too long. So in terms of installing Klipper screen, it was very, very easy. I basically went to here. I actually missed this bit. I know, I think I did do this. I didn't do the auto install, I did the manual install. So installing Klipper and Moonraker, which is basically by doing that thing with the Raspberry Pi image that will get you main cell. The main cell image includes those things. And then you just copy this and paste it into a remote session with the SSH, like this. So you do this thing, you log in, change settings, appearance. So you log in, Pi, Raspberry, and that yeah, you know, you get the drill. Copy that into there. Job's a good one. It's not Control-C, Control-V in command lines, because Control-C like cancels the current command. So typically it's just a right click. So if I copy this with Control-C, and I just right click in here, it just pastes immediately. So that's how you do that. And then for the Moonraker configuration, again, that's update finished, very nice. So your Moonraker configuration file is in here, and you just go in here. Tells you to add this, so you typically don't need all of this because this will already be here and this will already be here. You just need these numbers at the bottom, which is actually like basically an internal IP address. Oops, a daisy. So you add that in there as under trusted clients, like so. And then if you want to do the auto updates, which basically is the thing that I showed you just now, this, in order to have this update manager, you add this extra bit of text, literally just copy and paste into here, right, bosh, done. Save and restart, jobs are good. So that's where we're at. That's how much I've done versus not done. Middle mouse button. What does middle mouse button do? Oh, it's... Huh? Middle mouse button for pasting. So if I copy this, it doesn't work for me. If I middle mouse button, it highlights the whole line. But if I right click it, oh, didn't want to do that. Oh, that immediately copies, but left click does as well. I don't know why I actually searched that. I just wanted to paste it somewhere. Anyway. Anywho, anyway. I've just realised I forgot to get water, so I'll have to have a break at some point to get some water because it's blooming hot. So I've also made myself a little document of things I need to hopefully do. It's not finished, but I've started it. Oh, what I have also done. It just is like a narration live stream now. It's like doing a live guide. The next thing was flashing the firmware to the control board. Again, probably something you've seen 100 times, but I did it slightly differently. I might actually just do it again. We'll just repeat the whole process. Is that worth doing? So what I did is from here. So first you build the firmware. This is probably a thing you've done a million times before or seen before, where you do the make config, you have this window and you set up the things that you need to do. The thing I did a little bit differently, normally I would use the SD card firmware install. I don't like how they've got thin red text on a dark background here. It's just impossible to read. Anyway, normally I would do SD card, so you get the bin file, you put it on the SD card, you put it in the thing, and then you wait, and then it does the thing, and then you can check it, and all this kind of stuff. Kind of fine, it works. You can do that. In this instance, I used DFU firmware installed. Now, I don't actually know what DFU stands for, but basically it means you can flash it directly from here over the USB connection. So, I don't know if I can do it again. Oh, if it's worth doing again. So I basically just followed the instructions. Isn't that great, eh? It actually just works exactly how it was meant to. I install the jumper to a easiest method is firmware.bin on SD card. I don't know. This was. I'm going to demo this because I think it was easy. So it might be useful for people that want an alternative. So the first thing to do, I'm going to do is shut down the Raspberry Pi. I'm getting good at doing this now. I didn't used to do this. I used to just unplug it, but I've started doing this because now that I've killed a Raspberry Pi, I want to take as much care of them as possible. And you can't even buy new ones. I mean, it's normally the SD card that fails rather than the actual Pi when you do this, but anyway. So that's everything off. So we're going to remove power from here because we want to be able to control the power to this and this separately. So this is the power cable. From official Raspberry Pi thing, it's just plugged in down there. So nice chunky power cable. But it doesn't have quite enough power to actually power all the things that we want to. So I'm just going to unplug the stuff that we don't need, which is that and that. So we just have the Pi, the connection to this, and actually the screen as well. So now we're just powering up the Pi directly through here. And seeing as it's now off, we can install the Boot Zero jumper, which goes on these two pins just in here. You can find those. You probably can't see very easily from here. It's just in here. The schematic from BigTreeTech or the instructions there is going to be a better place to help you find it if you can't quite see it. So this should now be back again. Nice. So power off the Octopus, install the jumper, connect via USB-C, power on the Octopus. So now we're kind of back where we were just a second ago, but with the jumper on and the Pi powered separately. So now we're going to start the SSH session, and that's this thing via PuTTY, which is a tool for doing such a thing. Again, I can't really zoom in very easily, so sorry about that. You can just type your IP address in here, or if you've already saved one from before, you can open it. And I wish this would save the settings. Why does it not save the font? So from here, can we just do this? Okay. So LS USB basically is list USB. These are our USB devices. So if we see ours, there we go, that just makes them all on one line. So this is the one we're looking for because we're looking for an STM microelectronics DFU mode device. So our ID code that we need is this just here. As we discovered earlier, it will copy automatically just by highlighting. So that, as you can see, is named STM device in DFU mode. So now we need to run make flash device. Oh, we actually need to redo the make firmware because I hadn't done this. Let's go do that quickly. Can I just run all of this? No. Just need this. So this is what you have to do for your thing. So we need to set this up specifically for our control board here. Mine is the F446, so we're following this image here. Not over CAN, we're on USB. I think we want this. Actually, it doesn't matter, does it? 32. We want 12 megahertz for the crystal. (32 gigabit bootloader). Set the communication interface to USB. If you're using the GPIO connector power thing, that's via UART, but I'm recommending doing it this way. Yeah, basically last week the 24 volt power supply, I think has just outright failed. We had some problems with the USB being powered because it was a rubbish cable. GPIO killed a Raspberry Pi. That was just before the stream. I've gone over all the things already. You can do a quick rewind and that'll help you. You can have a quick look there. So once we've done this, we can quit with Q, and yes with that. And then we run make. Oh no, we didn't actually need to run make because we're going to run it directly via this command down here. So the command we're going to use to flash the device directly is this, but we need to modify it with the ID of the device that we had before. So when we did that ID search, we need that number there. So mine was this. So this is the command we need to run. Make flash device, and then the ID on the end. So we take that and copy it. I'll just prove that the LS USB was the device number. So this here. So if we take this lot, copy it, paste it in here. Fingers crossed, that's going to flash our control board. File download successfully transmitting DFU tutorial can't detach. Resetting USB to switch back to runtime mode. Okay, I don't know file downloads. I'm not sure. This makes it sound like it wasn't successful, but I think this is the same as what I got before. So power off, remove the jumper, power on. So we can just power off. We don't have to shut down the Pi, that's why we powered it separately. And then we need to remove the jumper, so be very careful. And I'm going to shut down the Pi now anyway, I think. All the STL for the screen mount should be in the bill of materials and Google Sheets link in the description. You should find that in there. It's not my design, so I've linked to the existing design for that. Let's just turn it back on. In fact, you probably don't really need to power the Pi separately, because like every time you turn one on, you can just do a shutdown, restart. It's not the end of the world. Device firmware update, there you go, that's what it's called. So now we can confirm with this. And now we have USB clicker, clicker? STM32F446, Now, I think we might need this later when we do our firmware configuration, so I'm just going to copy that in there. Useful little notepad file. Okay. So that's that. Hopefully that's clear enough. Now we have to do the software configuration, which is arguably the difficult bit. But I'm going to go get a glass of water, a water bottle, what's it thing, because it's hot and I need a drink. So we'll be back in like 30 seconds to a minute. I won't be long at all. Back in a second. Okay. So I guess this is kind of the point where we switch from story mode, where I just tell you things that happened, into like adventure mode, where anything could happen. So let's first shut down the Raspberry Pi so we can switch the power over back to what we had. And I think I found a way just to save those settings. So on Putty, when you have it's tiny screen this, isn't it? It's kind of silly. But you can save your things down here. So I can load, this is the one for this computer. If I go into appearance while I have that, and then change this, so there'd be 20 size, and then go back here, and save it, then it saves those font settings to that. So when I launch this now, it'll launch it already with, I mean, it won't do anything at the moment because the Pi's not running, because I shut it down. But that'll save those size settings, so if you want to have bigger text all the time, you can just load it like so. So let's get that power supply out the way now, and we're off the standard one. We can all plug in this showsum as well. So, as I said, this is where things do start to get I guess having to add the jumper is kind of annoying. I don't know if you can force a DFU mode without using the jumper. Because I know RatOS is able to flash firmware on some boards like directly. But if you have to add the jumper, I can understand that being a bit of a pain for most people. So yeah, not sure about that. It'll be one to keep an eye on or something. Especially in like an enclosure like this, where it's on the bottom, you'd have to literally like move the whole printer over, open the base, do the thing, do the firmware, do. You've got to get there for SD card anyway. Maybe it's not any quicker or slower, I don't know. It's basically just another method. So what we need to do really now, I think, is the actual firmware-y things. Basically the printer.cfg file, which is like the main configuration of the printer. So let's get this turned on. Boot it up again. So I think we'll try and follow this a little bit. Oh, what? Okay. Hello. Sure. So this is a example configuration for the Octopus. I don't know how we're supposed to just... This is the weird GitHub thing. How do you save this? Because if you save as, that's going to save the blooming HTML. I know what. That should be back. So we'll just create a file. think it's printer.cfg, or does it have to be a little p? Little p, printer.cfg, create that, open it, paste it in there. Oh, Control V. Nope, Control C, Control V. There we go. So we've got some macros in there, we've got displays, we've got expansion headers, gantry things, LEDs, heaters, probes, heater bed, all sorts of stuff. So we're going to have to go through this and make sure everything works as it should. Oops. Okay, yes, from here. Save as text, is that the way to do it? But it doesn't save as. Oh, okay, it would have done. Okay, sure. Fairy snuff. Please save the live. Yeah, the live will be there forever, it's fine. Found out last night the new FS1 V400 printer control pad can be used to run Klipper on any printer with no install. Run Klipper on any printer with no install. I don't know what the control pad is. Is it just running Klipper screen? Because that's a standard feature for Klipper screen, I think, if I'm understanding what you're saying. Right. Oh, we weren't looking at the second screen. So, you can have my mug down in the bottom corner to keep you entertained whilst we try and do this. Flash device, that's the other one. No worries, Chris. Just use your dev serial by ID as the flash device in Make Flash. Oh, and that does it directly without the DFU mode, does it? Oh, there's so many confusing things. I can't keep up. So, rename the download file. We've just copied and pasted it. Upload, Octopus, editing, main cell, notepad, review. Required changes. The following must be updated for the printer can function. Okay, so let's have a go at this. We're going to have some additional things to do because obviously we've got CAN control board stuff in here. So that's going to be a little bit interesting. I don't know how that lot works yet. So we're just going to have to make it up as we go along. I'll do my best. Cool. So, serial, I mean, I think we have this already, but we'll go get it again anyway. Just for following the instructions as closely as possible. Paste on that. There we go. Plain definition, serial device by ID is all of this, I believe, probably. Restart method is command. I don't know what that means, but sure. Max Z velocity, we'll leave that as it is for now. Max acceleration Speed settings I'm not too worried about. They're like a tuning thing, like as long as it's moving, that's the main thing. XY settings, B stepper left, connected to motor 0, in-stop connected to diag 0. I believe we have, oh, which are they? I think it's 1.8 for Z and 0.9 for the XY, it's like AB motors, sorry. So I think this is going to be 400. Oh, got something in my eye again. Typical. Oh, can we zoom in here? So B is left, connected to motor 0. I don't know if it's connected to motor 0. We'll just have to hope that it is. We can check when we get everything plugged in. We'll uncomment this because we have a 300 build. In fact, I'm going to get rid of everything else around it because Hamming speed, Hamming retract, Hamming positive direction. Stepper X is see, this is where we've got to be careful because we do not have 2209s. Control path. Printer specific settings. Too much opportunity. So we should have a few Okay, so we should be able to put right 5160 in here. It's not UART though, it's SPI. Ooh, there's one for canvas. Yes, it does need to be in SPI mode. We've set the headers up for SPI mode. I just got to find out how to do that in here. If we look for this, maybe that, oh, no. Okay, so we put MC 5160 here. To use this feature, to find a config section with 5160 prefix followed by the name of the corresponding stepper config section, for example this. The pin corresponding to the 5160 chip select line. This pin will be set to low at the start of SPI messages and raised to high after the message completes. This parameter must be provided. Cool. So we have a CS pin instead of UART pin. I'm guessing it's not going to be this. Need documentation. So Let me know if I'm going through this too quick. I can't imagine I am, because it's not very fast, but I do want to at least make sure you can follow what I'm doing. Okay. Oh, there's a firmware thing here. Proximity switch probe is no longer multiplex with BL touch as separate I/O. Okay. Images, hardware. Pin out. Okay, that's not terribly helpful. Oh no, here we go. Here we go. So, CS pin for driver 0 is PC4. That's weird. UART pin. I guess the UART pin and the CS pin are the same thing. Are they? Step is PF13, enable, PF14, direction, PF12, and CS is PC4. Okie dokie. We can stick with that then. Oh my days, there's so much stuff. Hello John, Gadget Angel. BigTreeTech has an example SPI config file. Maybe I should have a look at that. So this looks like the Physics Spider firmware Klipper UART, USB printer CFG. Is there a SPI here? Oh, it's in Spider. Make sure to update below for your relevant driver. Soft SPI. SPI software Meso SCLK. CS pin, interpolate, diag, run current, hold current, stealth chop. So they've just added this. I'm not sure why you need all of that. Software. I mean, obviously those are for the communication, but here, common SPI settings section for a description of the above parameters. Common SPI settings. The following parameters are generally available for devices using an SPI bus. The SPI speed in Hertz to use when communicating with the device. The default depends on the type of device. If the microcontroller supports multiple SPI buses, then one may specify the microcontroller bus name here. The default depends on the type of microcontroller. SPI software SCLK, Meso. Specify the above parameter to use a software-based SPI. This mode does not require microcontroller hardware support. Typically, any general purpose pins may be used. The default is to not use software SPI. Oh, not this. Driver SPI, here we go. So this is going to be for software. Does this... This is a software-based SPI. Is there no hardware-based? Is this like a... I would have thought... RatOS is so easy in comparison, isn't it? The default depends on the type of microcontroller. See, I think these are all optional. I think by default it will choose the only one available. And if there's only one SPI bus for this chip, F446. Can we look for SPI bus? 4. Okay, I don't know if this is... I've not been to this website before. I know it has all the information, but I don't know how to use it. I'm going to try. I mean, it feels lazy, but I have a sneaky suspicion that if I'm lucky, it will work straight away. I've lost the thing that I was... Where's the page I was using? Is this it here? SPI bus. Yeah, I mean, it doesn't... The only mandatory one is going to be CS pin. It should use defaults for everything else. Correct me if I'm wrong, but I think the worst case scenario is we have to enter it in later. I can't see this being a failure point. Step X, full steps per rotation. Okay. Why is there half the settings? Oh, because I joined them here. So again, we got this, and then we uncomment this. So we can take out all of this. We can take out all of that. Homing speeds are still the same. And then this is going to be, again, 5160. We should have still PD11 for the CS pin. Tell you what, I'll put these things in now. Let's go. We can drop them in, and then if we don't need them, or we'll just put them in but commented. Where's the... Here. Soft SPI. Software SPI. Do we need software SPI? This is the question, isn't it? software SPI. So the Mosi pin, so we have it here, is PA7. Miso is PA6. And SCRK is PA5. I'm using the BigTreeTech Octopus Pro STM32F446. So I believe we use the same SPI bus for every device. So we put the same settings in here if we do use them. Whew. This is complicated as heck. And I'm not even going to get the advantage of having 48 volts because I still only have 24. Maybe we'll find a way to add in a new 48 volt power supply at some other point in the future. We got the pinout diagram, that's here. That's what this is all about. That's this diagram over here. But I'm looking for the SPI hardware on this. This chip in the middle could have a couple of pins over here for SPI, could have another interface for SPI somewhere else, and the firmware can then use or not use those SPI buses. So here, look, there's SPI here. This is SPI 3. And there's another SPI here. So I think there's 4 SPI interfaces. Because that's sort of what the documentation suggested. I don't know what else is using SPI. But I think we have 4. Does it say driver? It just if this was labeled like SPI 1 or something, that might be helpful, but what on earth is going on? Some banging around going on outside. Oh, I'm getting very warm. It's all very well having a fan to blow air at you, but when that air is also hot, it doesn't help so much. I don't know why we need this enormous thing here that's blocking half the screen. Right. What's the temperature here now? It's probably not so bad now. I think it probably hit like 32 during the day. My phone says somewhere, it's either 28 or 27. Hang on, there's a lot of banging going on outside. I just want to check what is going on. Back in a second. Not quite sure what's going on. I think someone's like banging a rug or something against a wall. Someone's trying to do some aggressive cleaning or something. It's okay. A better pinout diagram. Color pin. Oh, it's this complicated one. This is like the most disgusting thing to read ever, isn't it? It's like a information vomit. Oh, we've got STM32 datasheet though. That could be useful. UART SPI. I need for this mode, jumps located here. The stepper motor drivers share the same SPI bus as XP2 and the Maxi 31865 chip. They only share Muso, Mosi and SCK lines. They have separate CS lines. So there is only one SPI bus then, maybe. Dual mode quad SPI interface is what it says. Specialized communication interface targeting single, dual or quad SPI flash memories. Okay, I don't understand this at all. Oh, this was done by Gadget Angel. You're literally right here. There are 4 SPI buses. The schematic. Let's go have a look at the schematic. So where's the... Whoops, it is. Okay. There's only so much tolerance I can accept for... Oh, did it not? Download. Schematic. Download. Right. So if we find the processor, which was down here somewhere, we will see, hopefully, things labeled as SPI. Or maybe not. SPI, SPI3, SPI1, 2. Oh dear. The spider board uses the same chip. I think you have to find this. It won't work because they use different pin names. We just looked at this. Where was the spider configuration? Software SPI. See, that doesn't. This doesn't specify the SPI bus. So we're just going to go with no SPI bus definition at the moment. We may put it in as not needed. It will use the default. Okay, now for Z. So Z0 is front left, which is this one down here, and that it wants connected to there. Motor 2. 0, 1, 2. I think it wants it here. Can we turn this off? Not easily. You shouldn't switch motors around while it's powered on, it causes failures. So I'm just going to make myself a little diagram. Oh, that's not a great diagram. Front left, right. Front left. Motor 2. Z1. Motor 3. Rear right. Z2. Motor 4. And front right. Z3. Motor 5. You'd think someone does, but I don't know if they do. If it's not been shared, or I can't find the person who has it. I mean, I kind of wanted to faff around trying to do it myself anyway. Apologies if it's not what you wanted to see, but I fancied doing it, even though it is mildly torturous. So, back to our basic Z configuration. Gear ratio, it's all sorted. Pins, rotation distance, blah 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 blah. Z position of nozzle in millimeters to Z end stop trigger point relative to surface. Okay, that's for this. Increasing position end stop brings nozzle closer to the bed. After you run Z end stop calibrate, position end stop will be stored at the very end of your config. Why is it not 0 to begin with? Oh, because it keeps it further from the bed. Okay, sure. Position max 260. Position min -5. That's a bit weird. Sure. We are using 2209, so this should all be the same. This should all be the same. This is all the same. Cool, 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 cool. Doopy 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 doo. Extruder. So this is where this is going to get a bit weird, because I've got this CAN board and I need to set that up. I don't know exactly how to do that, because this is not going to be right. This will be exactly wrong. I think this is going to be fine because we are using that driver, but it's on that CAN board. Discord doesn't seem to want to launch at the moment. Maybe because I'm... Discord seems to be dead. Or it's just because I'm running 100% system utilization at the moment. We're an hour and 10 minutes in. I knew it was not going to be quick. Run current 2.5, hold current 2, SPI bus, SPI 1. CS pin is the same, hold current's the same. 5, 6, 7. 5, 6, 7. Yeah, so I think I've got it. It's just whether the default, if the default SPI bus is SPI 1, then we're fine. I think we'll just stick that in there and in here, and then we can turn those on if we need them. Now, CAN control board thing. This is very new ground. So, obviously these pins here for the extruder are referring to pins of the main control board. We're communicating from the Raspberry Pi to the CAN, USB to CAN, and then to that secondary CAN controlled control board. So those pin references are just wrong. So we need to be able to reference something on a separate CAN-based control board rather than these. How do we do that? That's what we've got to work out. CAN bus. Klipper can support CAN on STM32 or RP2040. In addition, the microcontroller chip must be on a board that has a CAN transceiver. Compile for CAN, make menu config and select CAN bus as the communication interface. Finally, compile the microcontroller code and flash it to the target board. So this is where I have no idea. I kind of tried to do this, but I also didn't really know how. I guess we're going to have to turn it off. Okay, so we have to do a make menu config, so we have to go do that again, but for, let's save and close this, and we're going to have to do a restart. Let's do, okay, we're going to have to do this. So, oh no. Rubbish keyboard, can't type fast. Oh no. What? I had caps lock on. Maz on the UK Voron Discord has a guide. Are you able to share that guide in my Discord? Pretty please. I think you're right, just to find the CS pin it will default to SPI1 bus. This was my thought. And I think it's something, hopefully, that would have been considered when they designed the board and stuff. Like, if they know the default is like the first one in the list of available buses, put that as the one that's not pre-configured for something else. So when you enable it for drivers, it goes to that. Da-da-da-da. And if it doesn't work, then we change it to be the one. So there you go. So, oh, we have to CS Klipper. So I don't know if am I flashing this for the EBB36 or for the U2C? I think it's for the U2C, which is doing the communication. This is like its own little motherboard, as well as the other one being its own little. So I think for this chip. So I think I've got a. Oh goodness me. So this is an STM32F072C8. So STM32 processor model 072. Bootloader, no idea. Stick with that. Don't know. Interface, CAN bus. Oh, we've got more options. It's not that. USB to CAN bus bridge on PA11, PA12. No, it's not that. Klipper CAN bus guide. Okay, let's have a quick read through this. Assumptions: working instance of Klipper, access to Raspberry Pi, CAN adapter, waveshare, not the one that I'm using, hopefully it's so fine, and a CAN toolhead board of some variety. This guide and a brew or a coffee, sure. E-controller page has a set of safe default settings which should work for the majority of users. You should initially set up your controller based on these values, as these will inform some of the settings to be used for your control board of choice. Vehicle standard for communication, yep. Wiring layouts, CAN able, CAN to USB, Oh, Fly UTOC, that looks literally identical to what I'm using. Bridge adapters, user printer's control board as USB to CAN adapter, special bootloaders, CAN boot, toolhead boards, example configurations. Not all toolhead boards use the same wiring. Yes, this is weird. Oh, they've got a 1.2 now. Mine's a 1.1. Important notes. The boot pin is pulled high during DFU mode. This pin is shared with the heater and will cause the heater to heat. Removes 24-volt power when entering DFU mode. Oh my goodness. The probe port only supplies 5 volts, so you may not work with certain inductive probes. Pinned or peel touch style probe will work fine. Flash the CAN boot firmware via DFU on EBB36. Before proceeding, it's critical that your CAN network is configured for your printer. Failure to set up the CAN network will cause a problem when you try to connect devices. Click here and select the controller for setup instructions. Oh my goodness. I'll go with this. Okay, so I think that's what I was talking about here. Auto CAN, iFace, CAN 0, Just follow the user manual. This is what I was, but there's not much in it, is there? So I was thinking I need to actually deal with this, but if I don't need to do that, and I don't need to do this, this information here seems like it's not in an ideal place because it suggests you need to do something before you do this. Yeah, that's for that. Okay. Doop-a-doop-a-doo. Enter command in SHS terminal sudo nano. Isn't that edit a file, CAN 0, and execute? How can you execute that? Okie dokie, right. Where's our terminal? Did I turn it off or did I keep it on? Let's quit out of this. How do I? There we go. Do I just put these in this file? Bitrate is the speed. Must be the same as the speed set in the firmware CAN bus speed. Save after modification and enter. Okay. Just exit. Save, yes. To right. What? So that's done that. Okay, let's reboot. Man, it's complex. I think it's simple once you know what bits you do need to do and what bits you don't need to do. I was thinking I need to do this, which is why they put it in here. Like, do I need to go flash this Candlelight firmware to the board? It would make sense that it's already on there, but you never know, do you? Okay. We've done this weird sting and the thing, set that to that. Reboot. Every device on CAN bus generates a CAN bus UUID based on the MCU's UID. To find each microcontroller device ID, make sure the hardware is powered on and wired correctly, then run this lot. Total 0 UUIDs found. If an uninitialized CAN device is detected, the above command will report the device's CAN bus UUID. If Klipper is already running and connected to this device, the CAN bus UUID will not be reported, which is normal. So have I done this correctly or wrongly? I don't know. I think we need to probably find the instructions for the EVB36 as well, because that could be useful. Uh, 1.1.36 user manual. Download. This is the U2C user manual. File, open. Right, the next thing. I have the jumpers. Which jumpers are we talking about here? If you're talking about the 120 ohm resistors, yes, I have that and I measured them. Oh, for those that don't know, so on CAN bus, it's basically you have like a high line and a low line, and at the end of each line you have a 120 ohm resistor, and they must be at both ends. So when you measure across your CAN high and low with a ohmmeter, multimeter measuring resistance. It should measure, well, the result of two 120 ohm resistors in parallel, which is the sum of them divided by the number of them, 60 ohms. So with it powered off, remember it's off, measure across the can high and low, and you should find 60 ohms. If you don't, you need to make sure you're adding those like thingies across, where on the board it normally has a little pinout thing that says a little like silk screen text that says 120R. So you bridge that and that adds in the resistance to the can high low. So one on here, one on the other board, that then measures 60 ohms. Job's a good one. V-bus jumpers, I believe, is for USB, correct? And there is no USB. Oh, that's just my face. I don't have it connected to the Octopus. Remember, this is USB to CAN, not CAN bridge. So we're going Pi to CAN bus to that, and then, well, yeah, Pi to this to that, and then this to that. So they're both bridged from the Pi. So product parameters, firmware support. This product currently only supports Klipper. That's fine. Peripheral interface, how to plug stuff in. Hopefully that's fine. After the motherboard is powered on, the yellow-green LED 1 lights will light up, indicating normal power supply. The V USB on the right side of the board is the power selection terminal. Only when using USB Only when using USB to supply power to the motherboard or need to supply power through USB do you need to use the jumper cap to connect via USB. So you can see down here, this is the light for the power and this is the V-bus thing. So voltage over USB. I don't know why this says V-bus and this says VUSB. Anyway. Version without 31865, no need to plug a jumper cap when using 100K NTC. The TH Stereo's pull-up value is 4.7K. Do this for this, do this for this. BL Touch. Filament run-out detection. I'm using a different filament run-out detection. Yeah, I have the 120R on EBV36. That's RGB wiring. After connecting to the Raspberry Pi via SSH, type the following sentences. Sure. Compile the firmware the following. If the options are not available, update Klipper. When the configuration is completed, type Q, yes. Enter make, compile. You need to generate on home, Klipper out. Computer firmware left hand side, SSH software, user download directly to computer. Needs to jump to the system area to run bootloader. When using DFU to update firmware through the Type-C port referring to description manual, the initialization of this process, of this bootloader is shown in the following figure. After going to DFU, PO2 will be configured to output high level by bootloader. PO2 is used for the hot end. The high level in the DFU mode change the hot end into heating state, therefore please pay attention to disconnect the main power V-in of the hot end when using the DFU of Type-C port to update the firmware, or ensure that the firmware update is completed soon and go to the normal working mode. Never keep MCU in DFU mode for a long time when the main power supply and hot end are connected. Oh my goodness, eh? Oh, here we go. Oh, this instruction. Why did I never look at this instruction before? This one's way better. Okay, there's so much stuff. Oh my god. CAN is like super duper complicated to set up, isn't it? No, my EBB is 1.1, so I have got to be careful with this. I'm not sure how I'm going to disconnect 24 volts. Oh, I guess I just removed the power input here. That would be fine. That's easy to do. We can do that. The difficult bit is going to be getting a USB cable into that blooming thing to actually do the flashing. That's going to be the hardest challenge of the day. Okay. So first, I'm going to remove the power to the board. The safest way to do this is going to be to turn everything off. So that will be what we do now. Where's my... So many windows. All the windows. Here we go. Ooh, we had a... Ooh dear, why did we have a thing? That's not ideal. I wasn't expecting to have a low voltage today. Okay, that's off. That's out. So yeah, I'd be quite tempted to get a different one, but I do not. So unfortunately we're going to stick with this. So let's get these out of here. We've got to be a tad careful, because obviously we don't want these two ends to touch, because that will create a short. So let's try and keep them as far away from each other as possible. We've got something we can put over the end. I think this will be okay. This is far enough apart. I don't think there's any way those are going to come together. Okay. So now this voltage does not go to here, so we don't get the voltage to the other thing, so no hot end heating up. Yeah, Wago is the one thing I was thinking. Shall I just do that? I think I have some pretty close by. Just stick this in here. No, don't work. Too long. Oh, I need a thing over it just for my own peace of mind. I've had enough problems with this builder already. Do 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 do. That's some added protection. No magic smoke lost yet. Things are looking good-ish so far, mostly, a bit. How do I get a USB cable in here without hurting myself or damaging the printer? I think we need to remove our extra something wiry doobly doodah. Why are my side cutters in a silly place? Hello, Alex. You must have gone through all of this headache. I cannot see a blooming thing. No, no. It's going to be very difficult for me to show you the this side of the little EBB control board thing while I'm doing this, obviously because it's already tucked away inside the printer, somewhat hidden away, and with the power and such plugged in, it's not very accessible. I'll do my best to describe what is going on as I attempt to do a thing. One thing I will need is quite a long USB cable. A yay long USB cable. Where do I get a long USB cable from? I don't know if I have a long enough USB-C cable. That's not USB-C. I have this one. It's about 10 centimeters long. Do I have this and an extension cable? Ooh, I think I have a red... Hang on a minute. I think the one I have in here might just be long enough. It's not very long. No, I don't think this is going to be long enough. Nope, we still need an extension cable. Oh, man. How can I get this closer to the print? It's not quite long. Okay. I'm going to go find a USB extension cable. I don't know. Oh, maybe I've got one in this box. This extra cables box. No, that's a cable I've cut off. Doesn't have two ends, let alone extension. Oh, what about this? That's a short USB-C cable. Oh, that's a longer USB-C cable. Is it long enough? No, it's the same length as the other one probably. That's a short USB-C cable. That's not USB cable at all. That box of magic cables does not have the cable I need. Let's have a look in the other room. I might be able to find a USB-C cable, extension cable, which hopefully I can then just plug on the end of what I already have. Ooh, this is an extension cable. Here we go, hopefully this will work. Ooh! Can you hear me fine when I'm in the other room? I assume you can, because the microphone's obviously wireless, but I don't have no idea how it works with walls and such. Here we go. Yes, we need the V-bus jumper. We also need to make the image to flash, so that's all. Okay, so I think we have everything we need now, we just need to do the thing. Right, so this is how to flash the EBB36, probably. Right, how do we do it? We go, no. We turn it on. That's a good first step. We're going to be making some settings for this. So hopefully we can restart this session. Nope. Hopefully we can restart this session. Oh no, here we go. This one's running. Pi. Raspberry. We're in. So cd Klipper. Bosh. Changes the directory. Make menu config. Copy. Paste. Boom. Settings. Here we go. Enable extra low, yes. Microcontroller, STM32, STM32GB. Oh, G0B1. That was the one. Bootloader offset. No bootloader. Clock reference, 8 MHz. If using USB communication over Type-C, USB on PA11, PA12. If using CAN bus communication, yeah, I'm using CAN bus. CAN bus PB0, PB1. So this is going to be, as far as I understand it, the communication from the board that we're flashing to whatever's controlling it. So not from the Raspberry Pi to the USB CAN or anything from there. It's just from that board that's on the hot end to whatever controls it, which in this case is CAN. Bus speed we need to set at 250,000 so that it oh no, hello, oh no, no, oh no, 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 no. Why are we not? Okay. I tried using numpad and it went all weird. So 250,000 and not that. Quit. Yes to save. And then we run only after this is merged into the main branch capable with the official firmware support the CAN bus function. If you use CAN bus communication, you can use the firmware canbus.bin compiled by us on our GitHub. Okay, we have this now. This is implemented, I believe. Merged, yeah, good. When the configuration completed, type Q, exit, select yes to save. Enter make, whoops, a daisy, make. And that will generate the file that we need. Oh, you can, we already got that here, Alex. Twas shared already. It's helped us get to where we are, but the BigTreeTech documents are actually all right as long as you know where to look. Okay, that's now made it in this clip out clipper.bin file thing. So we're going to close this and open the other type of terminally SSHE thing, WinSCP, which is going to ask for loads of updates. Do I want to delete past temporary folders? Yeah, sure. New session, new site. 2.168.1.118. Save. Log in. Yes. Username pi. I don't know why I asked for that there. Oh yeah, because it does work. Okay, so home pi clipper out. Home pi clipper out. Clipper.bin. Copy. Livestream data. Paste. Don't need that. So that's now the file that we're going to flash to the EBB36 board with all the settings on what we need. Now we actually need to do the flashing. Okay, so now we have to do the actual flashing. Where is it about the pin thing? So this is where we need the VBus VUSB. So if I understand at the moment, it will not be powered on because there's no 24 volts. Correct. So now we have our big USB cable and this other tiny little USB cable. Are you running Ethernet into the printer? I am, because at the start I went through some of the issues I had configuring. I found that with the BigTreeTech Pi TFT50, it absolutely just killed the Wi-Fi. It just didn't work at all. Hopefully this is not going to kill the computer that I'm currently using, because, yeah, kind of using it at the moment. As things have gone pretty poorly in previous streams, you never know what might happen. So we need to add a header on here for VBus. 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 I think. It has a extra tiny header thing pin, doobly. I need an extra tiny thing to go on it. Extra tiny jumpers, here we go. I don't know what pin dimensions are. It's not the standard 2.54mm pitch. It's extra tiny. Okay. VBus bridged. I feel like, why do I need the CAN connection? Can I just remove that entirely? Why can't I just do this? Oh, because it's difficult to take out. Like, I don't need that CAN communication at the moment, do I? That saves any risky business from going on. Okay. STM32Q programmer, which I downloaded earlier. Open file. Clipper.bin. Ooh, look at all of this fancy things. Nice. Press and hold the boot button and then click the reset button to enter DFU mode. Is this assuming it's already powered on? How do I get my fingers in here? I can't reach that. It's covered. How is this possible? Fucking mental. Tiny things. It's too tiny. I need a stick thing to poke in there. It's plastic, so I don't short anything. Here we go. This is a stick thing. Press and hold the boot button, then click the reset button to enter DFU mode. Nothing seemed to happen. I don't know if that's in DFU mode or not. Click the refresh button. USB. No DFU. I wonder if this is just one of those dodgy power-only USB cables. Winners will be at the end of the stream. Click the refresh button until the port changes from no DFU to USB 1. Click it until it does. Just click it forever. Okay, so clearly something's not quite right here. Are you telling me I'm doing something wrong? I can't really watch a video while making a video. There we go, it was a dodgy cable. Okay, now we'll try this. Hold the boot pin and press the DFU. There we go, USB 1. Yeah, so this cable is one of those shitty ones that's power only. USB 1, connect to the chip. After connection is successful, connect will change to disconnect and then click download. After download is completed, a pop-up window of the file indicates the is successful. Download. File download completed. Interesting. I'd call that an upload, but there you go. Whichever way, it seems to be done. Disconnect. The buttons are on the back of the EBB36. Well, sort of the front / the back, depends which way it's facing, I guess. Okie dokie. Oh, everyone's gone quite quiet. Hello, Giga Chad. So, now we can probably do this thing with the thing. We need to plug our thing back in. Got to be a bit careful with that because it's not got the cables on. Now this is back. Let's shut this down, get this plugged back in as it was. Oh, we need to disable that V-bus connector. Let's put that off. connect back to the Pi and shut it down. Shut it down. Shut that down. Watching you struggle. I'm not struggling. Last stream I was struggling. This stream I'm just slow and taking my time to try and do it right while also learning as I try and do it. Yes, it's bus ID time. But we're also going to put this 24 volt Watts-a-doobly back. It may be smart to leave this out. Let's leave this out for a second. Ooh, occasionally when I turn it on, the monitor goes black. I don't think that's a good thing. It's like a power inrush surge thing. I'm not sure it's meant to happen. Oh, because the board won't be connected, will it? Because now it needs the power from the 24 volts. Oh, what a dipstick. Right, let's go and shut it down again. Bo-ba-doo-boo, ba-doo, ba-doo, ba-doo. Shut down. Sorry, Pi. You probably didn't want to turn on and off and on and off and on and off. No, 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 no. Pew! It's weird, like the speaker seems to start making a buzz as it turns off. I don't know why. Okay. Okay. This is indeed Octopus Pro. Right, let's go find some CAN adapter thing, ID number, what's its. Okay, is this command that we need? And we need a putty session. Yeah! Found CAN boss UID, doobie looby looby loo. Yes. What do I do with that? Enter the IP access of Raspberry Pi in the browser of the computer. Download the reference configuration of the motherboard. Upload the motherboard configuration. Include sample EBBB CAN bus V1.1 CFG. Okay. So we need new. We need the separate. Yeah, I removed the VBus jumper. There should be. This is saying there's a BigTreeTech EBB CAN bus config file. Revise the ID number, the configuration of radio files is the actual. Oh, this is just a. I think we can just do this. 1.1. There is a fair bit in here. Okay, cool. That's cool. Cool. Get this. Save as. That. And then we'll go back here. We're going to upload this configuration file. Where's that gone? Oh, wasn't I just... Oh no, it's in stream data. This CFG file. USB Klipper Firmware. I don't know what this means. Okay. No, okay. Where's it gone? Add the motherboard's configuration to... Oh yeah, we need to do the include. Oh, why does it have to have such a big name? So we'll put it up here. So now it knows to reference this. Revise the ID number of the configuration files as the actual ID of the motherboard, USB serial or CAN bus. So I think we just need that in here and not this. This would be if you're doing it via USB, this is if you're doing it via CAN. We are doing CAN, which we've been over a million times, and this is how you reference those additional pins. So this is now all the configuration for the extruder. You can see it's got the TMC driver, the fans, the heaters, all that lot. So for referencing like a sub-module pin, it's the name of the module, colon, space, and then the pin on that module. So we've got near pixels, BL touch, filament sensor switch, motion sensor. Cool. Don't forget to set the executable bit using chmod X on your network if it isn't already. My CAN 0 was set to 10 before I did that and it caused buffer errors. I can't pronounce your name, KDS 12345, whatever it is. What I did do, if this is what you're talking about, is this bit. I set that, whatever that is. Unfortunately, I don't understand a lot of this. I am just following what it says to do. So in here, so we can save and close this. In printer, we need to now turn off the extruder configuration, this lot. We don't want this. Rather, what do we need? We don't want this. We can probably keep this. Maybe keep this. won't work, this won't work. Min temp, max power. Minimum extrude temp, control, PID. Pressure advance, we can put on at something tiny. And E0 motor we don't want. Its current value with ifconfig. Okay, we can try that. Where might one check this value that we're looking for? TXQ length. Transmission queue length. 1024. Extruder rotation distance. So we don't really want the rotation distance set in here. Heater pin will have sensor type. Now we've got to get that correct for the hot end. Oh dear, what's the... We have a Fetus Rapido. This isn't loaded well, is it? I'd like some product information for me to do my configuration, please. What is the thermistor? Thermistor 104 into that. Okay, it's like an image. Why does it? Let's go here, Control F in here. Common thermistors are that. Okay, I think it's this ADC Semitech 104NT R025H42G. Yes. So we'll take this, put that into here. I'll put a comment. Control PID. We don't want the PID values in here. What's the maximum recommended temperatures? Elements maximum heat resistance 290. Heating power 24 volts, 115 watts. That's ludicrous. I'm tempted to put like the maximum heater power to like 50%. It goes to about 50 watts at 200, so it drops quite quick. It does seem a bit extreme. Maybe we'll put it at like 80%. Max temperature 290. It's not that hot. You just need plus X. $sudo chmod plus X. Okay, I appreciate the additional assistance, but I don't understand it. We'll leave it as it is for now and check if it works, and try that if not. Okay. Run current. We've got to be careful here because we don't want to absolutely wreck the motor. 0.65 is, I believe, the very limit, so we might just try something a little bit under. Fan, heater fan, hot end fan, heater temperature. So hot end fan, that's gonna, okay, so one of those will come on at 50. We can check which one and then configure from there. NeoPixel, we'll add this. We can turn off any NeoPixel in here. Okay, we don't have we don't have this or this. Output pin for the beeper. Display. We don't need this, don't need this. I'm not sure why the beeper is a pin, so I don't think we need that. Just do the command he gave me. $sudo this. Command not found. So that adds this plus X parameter to whatever chmod is. Patch file, how to use the command. Chmod plus X on a file, your script for example, only means that you'll make it executable. Right click on your script and choose Properties Permissions, allow executing file as a program. Leaves you the exact same result as the command in terminal. So it makes that commute. Okay, right. We're getting some progress. Sort of, slowly. We haven't done camera, we haven't done BigTreeTech filament sensor. Let's give that a go. Let's stick that in, shall we? I think I have a little linky for that. So, smart filament sensor Klipper configuration is this. We can pretty much just bang that in. I think I tend to put macros in a different thing. Display pin speed. Okay, we still got some stuff to do in here actually, quite a lot. Let's put this in here. PA9, is that where I've got it plugged in? That is the question. Probably not. We have it plugged in up here on this one here, J33. End stop 3 is PG11. That's a good point. I don't know which round my motors are with my we need to check those. So I think I did X, Y, Z, E from the bottom. So X end stop pin, PG6 is what I did. Start PG9. Oh, I'm good. Sorry. Where's the end stop pin? PG10. Yes. Then PG11 for E. Okay. Extruder. So this is just going to do our rotation distance in this file rather than in the other one. Min temp, max temp, min extrude temp, control PID. So this really we only want these specific things for. I'm going to take this up here as well. Should probably move this up here. Sensor type, heater pin, sensor pin. Yeah, that's going to go because that's on the thing. Min temp, max temp, this is 290. Min extrude temperature 170. Doobie 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 doo. Okay, E0 motor, we don't need that. Bed. Other wiring guides, use bed out to control the SSR. So where's PA3? Extruder is on CAN bus, but I believe if I put this here, it'll just overwrite the parameters that it imports from there. So it'll start by doing those pins. It'll assign pins from the other file to extruder, and then it'll add in this rotation distance and other parameters when it gets to this, as in like when it reads through the file. That's my understanding. PA3 is heater 1 here. So, no, we've used bed out. I don't know why we've used bed out, but we have. Heater pin is PA1, so we've got this one down here, PA1. Yes, heater pin is PA1. Check the thermistor type. Generic 3950 for Kinovo heaters. .4 watts, so 4 kilowatts per meter squared. This is the fine max power. Can't we do? I'm pretty sure we do 100 for this because it's kind of low. Oh, 1 rather. Temp, max temp, PIDs. How long will we be doing this? I feel like we're making good progress. I know it's quite slow. I can't believe it's still warm here. It's like 10 to 10 at night. And the temperature, current temperature is reading 24 degrees Celsius. Flipping nuts. Probe. Okay, this gets more complicated now because I'm using the Pinder probe, which is mounted to the thingy. So we don't want this. We might want this. Do you remove the PID settings for the bed like you do for the thermistor? I didn't remove them. I'll leave them as they are and then do the tuning and then I'll fix them. Select the probe type. For the DAG 7 port, needs battery for change for Octopus Pro. NPM, so it's none of these because we're going to be using this. So I'm going to have a quick look up of probe. So where is probe? Configuration, here we go, probe. So is there Pinder in here? No. One may define a section to enable Z-height probing hardware. This is the thing. So we're actually going to put this in here. And we want to put it in as probe, not as BL touch. Pin is going to be here. I suppose we can keep this probe section, we just need to make sure we define the probe pin correctly. Multi-MCU homing. See the rotation distance document for information on calculate the rotation distance parameter. Klipper supports a mechanism for honing with an end stop attached to one microcontroller while its stepper motors are on a different microcontroller. This support is referred to as multi-MCU homing. This feature is also used when a Z probe is on a different microcontroller than the Z stepper motors. The overshoot occurs due to possible message transmission delays between the microcontroller monitoring the end stop and the microcontrollers moving the stepper motors. The Klipper code is designed to limit this delay to no more than 25 milliseconds. So for example, if homing at 10 millimeters per second, it's possible for an overshoot of up to 0.250 millimeters. That's quite a long way. Care should be taken when configuring multi-MCU homing to account for this type of overshoot. Using slower homing or probing speeds can reduce the overshoot. Stepper motor overshoot should not adversely impact the precision of the homing and probing procedure. The Klipper code will detect the overshoot and account for it in its calculations. However, it is important that the hardware design is capable of handling overshoot without causing damage to the machine. Should Klipper detect a communication issue between microcontroller during MCU homing, then it will raise a communication timeout during homing error. Note that an axis with multiple steppers need to be on the same microcontroller in order to be using for MCU homing. For example, if an end stop is on a separate microcontroller from stepper Z, then stepper Z1 must be on the same microcontroller as stepper Z. Okay, so this is actually going to be fine for me, I think, because we're using a non-contact Pinder probe, which will trigger quite a lot more than 1/4 millimeter away from the bed. We can allow that drift of 1/4 millimeter is there. So basically it's going to trigger and move an extra 1/4 millimeter before it actually stops, whereas normal it would stop basically as soon as it triggers because of that delay between one microcontroller and the other. We don't have to worry about it in terms of the leveling performance, but we do need to make sure we can do that motion. My Voron is a 300mm version. So we were looking for Pro before. So we do need to set the pin. We'll go do it in the other thing. It's not clear whether it needs to have a space here or not. So we need to find that pin out thing. Hopefully this will help us. I think there's a pretty good diagram in here. Yeah. So I think I attached it to this. Can't really see. Let's have. Yeah, second row up. So I've attached mine to end stop, which I've probably done 5 up ground, then X, Y, Z again. Hopefully. So PB7 should be my Z end stop. There's so much potential for this to just be an absolute mess. Got to be so careful when I start actually testing the printer. You don't just try and do everything at once. You've got to like methodically try a bit of motion, try a bit of movement, try a bit of end stopping, try a bit of this. Because if you try and do the whole thing at once, it's all just going to go to pot. Because while I'm confident I've done what I can to make this correct, there's every chance that I've missed a thing. Probe. So the Y offset is because the probe is like directly behind the hot end. Probing speed 10, samples 3, medium result, boop-a-doop-a-doo, okie dokie. Fan control. Fans on PA8. Hot end heater fan, so this can be disabled because we obviously have the one attached to the control board, the mini control board. But we do have additional fans. So we've got the, what do you call it, the filtery thing, forgotten its name. And this is where it's plugged in. So let's get these pin name number things. These are here. I don't know why I've plugged these in where I have. I sort of assume these first two are reserved for something else, but they're not really reserved. You can put them anywhere, but anyway. Print cooling, oh, this is print cooling fan. Also don't need that. Activate when you turn on the machine instead of when the bed heater activates. Why? That seems excessive because you only really need to cool the electronics when there's heat that's going to cause it to overheat. Yes, the part cooling fan is on the can. Oh, is it actually there though? That's a good question. Fan. There's not much. It's just a fan on that pin. And then heater fan, hot end fan. I think we'll keep this. I imagine the max power is 1 anyway. A bed trimming cycle on your cold bed. Okay, yeah, good point. So, I mean, basically we just disable this, don't we? Just means I don't really want them necessarily running 100%. Do we have a choice? I believe before, oh yeah, you can just set the max power. They might PWM weird though, and make strange noises. I guess we can use exhaust fan as our... Oh, I was supposed to be checking the pin numbers, wasn't I? Pin cooling fan, so that pin is on the EBB, that's fine. The hot end fan's on the EBB. Controller fan is... Oh, well, we've got two actually, because I've wired them into separate things. Is J52 and 53, PD12 and PD13. We'll call this controller fan 0, call this controller fan 1, and we'll call this 13, like so. I think that's okay. Or can I just add like a comma, PD12, PD13? Not sure. And it is pin. It's fine. Where did I plug in my LEDs? Is one of those LEDs? Have I forgotten to wire? I think I've forgotten to wire the thingy-doobly. This is LEDs. I've forgotten a thing. I have no... I don't think this is connected. Oh, I can't really get it out. I don't think I've wired this in. Good night, Lars. Thanks for joining in. LED for stealth mode should be on can. I believe it is already. But this is for chamber temperature, chamber lights. How long are we going? 2 hours, 36 minutes. So I think this one, the lighting that I've actually, the wire I've put in, I think we're going to move to up here. Ooh, and that's immediately turned on. Okay. So that's definitely the lights. Wow, that looks good. Look at all. Oh, you can't see the light. Damn. That's some serious light. Okay, so that's definitely the lights. It's suggesting putting them on the heater pin rather than the fan pin. I think the fan should be enough because we're going to PWM them. Static value. Value 0.2. I think we're going to do a save and restart. Oh, do we have to do heater fan pin? I think we're going to have to move these then. Everything that's configured here is going to have to go in the other file. Is it heater fan? Hot end fan? Yeah. Pin. So put the max power here. Start time here. Delete the rest of it. We'll get lots of these, I think. Yeah. Oh, there's nothing on here. That's fine. Points must be specified. I might just unplug these LEDs for now because I don't want them going maximum burst power. Okay, quad gantry leveling. Oh, what? No. Use quad gantry level to level a gantry. Min and max gantry corners measure from. Okay, we don't want this bit. We don't want this bit. But we do want this bit. Gantry corners, probe points. Horizontal move, retries, filament thing. Are we getting there? Oh, oh, oh! I think we've done that thing! We've done that thing! Multi-pin. My multi-pin pins. Multi-pin pinouts. One may define any number of sections with a multi-pin. A multi-pin output creates an internal pin alias that can modify multiple output pins each time the alias pin is set. For example, one can define a multi-pin my fan containing 2 pins and then set pin equals multi-pin my fan in the fan section. On each fan change, both outputs would be updated. These aliases may not be used with stepper motor pins. Okay, so let's have a quick go at this. Thank you for sharing that, by the way. Very nice. So we can just put this here. controller fan pins, comma separated list. So we'll put PD12, comma PD13, and then this, and then set pin equals multipin my fan. This is confusing because that's a different format. We don't put pin equals. It's pin multi-fan, multi-pin. Okay, so this, like this, I think that would be right. Let's have a go with that. Yeah, these are the ones in here are like the earliest version, the version 1.1 ones, whereas these are obviously the version 2 ones in black. But yes, maximum daylight, super duper bright. Pin controller fans use multi-pins. Pin controller fan pins used multiple times in config. Oh yeah, of course. Why did I? I'm such an idiot. The whole point of doing it is that I don't need both sections. I did share some stuff at the beginning, Kevin. Obviously you weren't here, but if you can only rewind 2 hours, can't you? You have to wait till after the stream. But there's like a 15-minute section at the start I talked about that kind of thing. Voron doesn't have to be this much work. I've done quite a lot of... Oh, that's so freaking sweet. Look at this. I've not used Klipper screen before. Let's just check my power cables aren't being overly stretched. You can see this screen. It's like... has all the informations on it. I know it's sideways. Sorry about that. And you could just, poof, temperatures. I'm not going to press anything too much now because I don't want to, limits, boom, stuff, Z-calibrate, limits, settings, network, boom, done, IP address, settings, boom, emergency everything, confirm emergency stop, auto close notifications, 24-hour time. Such a nice little thing. Yes! Yes! Right. What have we not configured? I feel like I've configured the absolute living wazoo out of everything at the moment. It's been a slow stream, but I think we've got quite a bit done. I was not sure that we'd get this much done. Webcams, that's the other thing. Have a webcam. They should be placed here, I think. So let's have a look. Oh no, not this. Main sale. I might just use my current. I have a webcam.txt. I think we'll just use this. Basically, to do a webcam, as far as I understand, there's not great... Oh, missing configuration. Okay. We have to do these. We just need to include... Okay. Webcam. Let's do webcam first and we'll do this afterwards. So, machine. We have to upload a file called webcam.txt which contains the configuration options. So, it looks a bit like this. The formatting is dog ugly, but it's basically, most of this is commented as you can see, but this is a USB camera, options of 640 by 480, like configuration options. There's additional things here if you want to check them. It should allow that to work. Hi Ben. Ben F. Is that 3 blobs of, I forget the colouring. The little V logos, for anyone that's interested, are for the YouTube members. So you get different colours as you become subscribed as a member for longer periods of time. So I think it starts on white and then it goes, I think Lars has been here quite a while, so I think the orange is maybe after green, but I forget. So you can become a YouTube member if you want to get one of those things. It might almost be time to do the giveaway and things. Dashboard. Encoder sensor. Oh yes. So we need to add these. So I believe what we need to do is include mainsail.cfg, and it's going to give us a thing. Here you go. And this is all the extra stuff that you need for that. So printer.cfg, we'll just add it in here. And that should be a little bit happier. It's going to take a little while to reconnect, I think. Boom. I'm interested to try out this job queues thing. Macros, machine, miscellaneous. So, can we see? I don't know how to do webcam. How do we do? Webcams. Add a webcam. Name. Webcam. 1. Great name. Save webcam. Oh, so maybe my configuration is now going to make a mess of this. Maybe that we don't need this then. Ooh. It's not sure about it. It's not an IP camera. It doesn't seem to be quite right. Let's reboot. Do you think that you would put a BigTreeTech M8P in this as an upgrade at a later date, as it has higher caps than the Octo board? I don't, yeah, maybe, sure. I do have one to use. I have quite a few control boards and things I need to test out at the moment. Why is heater 2 turned on? Sure, it thinks it's a thing. We can plug in our lights again now. That's come on at like maximum juice. Oh. Well, that's not worked. I also used the wrong pin. PB10 is not the pin. The pin is fan 7. What? That's the jumper. Oh, this is just straight voltage. Okay, that's not a thing, that's why. Okay, so we've got 2 of plain voltage, and then we can do the next one down. And that's PD15. Oh, we've hit another undervolt again. This is not good. So I've actually got a webcam set up on my rat rig printer here. And it's identical webcam, like the hardware is the same. MPEG streamer. So why do I not have MPEG streamer on my current? There we go. It's now reduced to a subtle glow. Oh, it looks it looks like an intense beam still on here, but it's much more of a subtle glow than it was before. I'm working on a design at the moment to add some like baffles to make them so they just shine inwards and not outwards, if that makes sense. Light-wise, that's much darker. There should be more appropriate light level and much less heat, because we don't want too much heat. I'm concerned about still getting this though. I think I've just got so much stuff plugged in. Maybe this webcam is dead. Have I killed the webcam? Install FFmpeg. And maybe that's why I've got after you. This is not what I'm after, is it? What a load of shit. Did you try to restart the webcam deprocess? I don't seem to have a webcam deprocess. I wonder if I'm missing a thing that I need for doing the webcams. What do I need? What do I need? I don't remember. I don't remember how I do it before. I have to install FFmpeg. Are we sure? Can anyone else verify that sudo apt install ffmpeg is going to be the right thing to do? Okay, let's give this a bash. The webcam is plugged in. Oh, it's also got a cover on, so all we see is black. That's not going to help. I have got it wired up via a slightly dodgy method, but it should still work. That being said, I've not tested it like this. I've not tested this camera on that printer or anything. The following patch was automatically stored is no longer required. Already, do you have a webcam text in your Klipper config folder? Yeah, that's here. Because I copied it from the other printer because I was lazy, but it is the exact same thing. Oh. So does this mean the camera is not connected? I'm guessing that is the case. One supposes that my slightly dodgy connection method is not quite good enough. People posting all these weird things. I don't understand what they do. I've rebooted the Pi like 6 times. Haven't I? Let's do a full shutdown. If all else fails, turn it off and turn it on again. Right. Oh, we've reached 3 hours. This is where the USB cable plugs in. This is the USB here. It's quite a few USB devices now. I can show you, because I've got a spare extra one, what it is that I've actually plugged in, if that helps. It should be on my desk here somewhere. I think I've got, or maybe I don't anymore. Maybe I tidied it away somewhere organised. Bu- 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 bu. It's not, I could obviously show you it as it exactly as it's installed, but not that easy to move the cameras to a place where you can see it. Oh, where do I put, I know I have a third one. One's in the rat rig. One's on this printer, and there should be a third. I remember seeing it recently, but I don't know, I don't remember where I saw it. Not here by the looks of it. Oh, well, it won't work now because it is unplugged. Because I unplugged it. I mean, my soldering job is a little bit dodgy, I'll admit. Minus USB, and he tries USB webcam and camera. Just kind of have it turn off and turn back on again because I had the camera not plugged in. Oh, I didn't include WebDAC. You don't have to, I don't think. Because it's not quite the same thing. No, it's not being accessed by the configuration. It just happens to be where you keep it. Right. Oh, the screen's gone off again. Good night, Ella. Thanks for joining in. In webcam.text, try auto instead of USB. That's a good shout. Oh, wrong one. Webcam. I mean, it's not a Raspberry Pi webcam. Maybe I wired it up wrong or something stupid. Oh, here we go. Yeah, LS USB is probably a good idea. I wonder if I've used another stupid device that does power and nothing else. So the webcam D service is still not running. Why is that not a thing? I'm not going to change the name of the fucking webcam. My USB webcam is indeed not working. This is an astute observation. Oh, no, that goes in here. Oh, that was a smart idea, isn't it? I wired the wire through the device. Now I can't get it out. Okay. Let's close this before it slams. He said, slamming it. Right, let's have a look here. Right, it's very warm, so it's been getting power. Let's have a bit of a probe around. Right. So there's no accidental crossing here. Ah, mother. That seems to be okay. My wiring is sufficient. So I guess what we can do now that it's out is try it with a different USB cable or something. That is more different, more shorter, or something like that. Hello, 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 hello. USB-C cable. Not this one, because we know that's just power. We know this one works. Let's try this red one. Maybe the cable's just too long and it's not getting enough voltage or something. Voltage. When does the stream end? Oh, God knows. Soon, I hope. Ask whoever's running it, they might know. Let's turn this on. We've had a pretty constant 60 odd people for this whole stream. Yeah. Thank you for buying them. So, webcam doesn't show up. We've had under voltage again. That's not good. Probably related to this then. I think this is, I mean, it's getting pretty warm. Maybe we'll have to not have a webcam or something. Oh. Good morning, good evening, good night, good day. What was that? This is just the same as before. I think this is balked. It's dead in some way. I don't have webcams on most of my 3D printers, to be honest. Let's see if I can find this sodding camera module that I have somewhere. Aha! Oof! So, this is that module. Let's try. Just this cable. So this is the cable that it comes with a completely different module. Brand new, out the box, never been touched. I don't know what this crow's nest thing is. Should it show up straight away? Oh. Well, that seems to be working. Silicon Motion Taiwan, formerly Fire Technology Corp, endoscope camera. Okay, so if I take that out, that should go away. Yep, and if I put the modified other one in to test, it should show up again. Yes, so the module is fine. The module works. So it's either the cable or this dodgy USB-C module. I could try probing in the cable. I don't know how to probe. How do I check that this is wired correctly? I need like another USB breakout on the other end. So we should have I think I've got my data plus and data minus the wrong way around. That could be a thing. Do you reckon that's what I've done wrong? I reckon that's what I've done wrong. That would make sense why we're not getting the datas, but it's still getting the powers. Or the data is at least very confused. Let's do some soldering to try and fix the problem. This is a Precision Gold A55KJ. It just was one that was being thrown out, so I borrowed it. So, now I have to carefully rewire this module. Not the easiest thing. Trizzers. I've just realised you can't see anything of what I'm doing. So I've just desoldered a couple of them, the white and green. Now I'm going to switch them over and solder them back. The white one I've put back on, I just moved the green out of the way so I didn't get caught up because they're obviously kind of trained in their positions now. So I tend to want to spring back to where they were, but this should work now. This to the side. Hopefully we can test this pretty quick. No, don't skip the camera. We must not skip things. We've already had to destroy our power supply planning. So take that out, plug this in. Plug the module into here. And then this into here. And then, as if by magic, yes! Still nothing. Okay. We're making progress though. What camera is it? It's a Silicon Motion Inc. Taiwan formerly fired Technology Corp endoscope camera. So then if I unplug that, you must reboot. We simply must. Come on. Oh no, that's not good. Whew. Oh no, not again. I wonder if I need to power the camera or something separately. I think with these rubbish cables, that's mostly what it is. Okay, now I think it's a software issue. It's definitely showing up. Oh, here we go. Woo, it's very wide. That's like such an extreme wide angle, it's insane. Quite good quality though. Nice, eh? Let's just call it the video thing. Does it work? Did not remove the lens, it does not work. Oh no, I wasn't planning to. Okay, cool. So hopefully if I unplug that, nothing's going to break. And I can get this cover back on. Get it wired back in the way it was intended. Right, now I need to install it back onto the printer and hopefully try it with the original cable. That should still then work as intended. If we can set it to a less wide angle, that would be nice, but I don't think that's going to be an option. The wideness of the angle does seem a little bit extreme. Oh, I do need to change the PWM rate. You can see, oh, it's weird. You can't see on the camera because of frame rates and all this kind of malarkey. But when you have PWM that doesn't, on lights that doesn't go fast enough, your eye can sort of see your hand in like multiple positions. So that makes the movement look really juddery instead of smooth, like a constant light. Oh boy, that's a wide angle. I've got to be careful. I don't want to. I'm using a metal screwdriver, so I don't want to short anything. It is also upside down. Yeah, we can fix that. And then, oh my god, that's insane. Why is it so wide? Oh dear. It's very fisheye, but it is a good observation. Like you can see, hopefully the whole build volume, even when it's printing like my hands, the tip of my finger is touching the top of the printer. Obviously this right here, this is right at the top. So you can see literally from the door, if I twisted it a little bit more, there you go. This is the frame at the top of the printer. This is the frame at the front of the printer. So you can see a full 90 degrees. Just makes my arm look like 15 feet long. It does look a little bit weirdly stretched as well, doesn't it? I'll give you that. That might be a webcam.txt thing. So yeah, this is the output pin. Oh, cycle time. There we go. So you don't get the weird frame, looks a bit more normal now. Look at that. Absolutely banging. I think I'm going to have to call it there though. So it's time to do a giveaway. So if you haven't entered, make sure you enter in the next 30 seconds. And then I'll be disabling the entries. I'll give you 30 seconds from now. Which is not very long, but it should be enough. Competition. Open up the wheel of names. Ooh, that's kind of annoying, isn't it? So we have 158 entries. There we go. You can't win both, so which one? There was a link for that giveaway. Mitsuma, did you miss it? If you were here, the comment is pinned. You have to click it and expand it, and then it's a Google Forms link. It worked for 158 people, so you might already be in it if you were here last time, because obviously I didn't draw last time. No, unfortunately you don't appear to be. So the giveaway, as we discussed at the start, we'll do a draw for a long and short white Daybreak PCB and a long and short Neo PCB. So we've got Daybreak and Daybreak Mini, Daybreak Neo and Daybreak Neo Mini. So which one should we do first? Obviously if somebody wins which comes first, they don't get an opportunity at the one that goes second. So which one should we do first? Should we do white first and we'll do the RGB one second? Or should we'll do RGB one first and the white one second? because the RGB is the newest one. So then, of course, how many times do we mix the names? We have to do a bunch of shuffles. Give me a single digit number for the number of shuffles. What's the shuffle going to be? 4 shuffles. Ben was in there first with 4. 1, 2, 3, 4. 4 RGB Neos. Daybreak Neos. The winner is... Oh, Ben F. It just went past you. Rasmus Armbrus. I don't know how to pronounce that, but congratulations. You are the first winner. Are you in the chat? No, unfortunately not. But that's fine, you still win. So remove you, because you cannot win again. We'll do 1, 2, 3, 4 more shuffles, and this is now the draw for the Daybreak and Daybreak Mini, which is basically what I've got in here, the Daybreak. Super bright white LEDs. Rick G. Hasn't Rick G already won something recently? I don't know. So there we go. That's going to be it for me today. Congratulations to the winners. I'll be in contact via the email address that you provided in the form. Thankfully, we have our configuration mostly up and running now. There's going to be plenty of fine-tuning. I don't know if we'll do that on stream or I'll do it in between, but next time we'll be like finalizing our configuration and doing a first print. So pretty excited about that. Yeah, we're all done. 3 hours, 40 minutes. That took a little while, didn't it? Would a Voron 2.4 be 3 daybreaks if one each side and front? Yes, I guess. I've not checked that it fits in the front. I'm sure it does. They're pretty same size extrusions. But yes, 3 would be, I guess, a kind of all the way around. I quite like them just from the 2 sides, but you know, you do you, up to you. You could do 3 if you want to do 3, that's absolutely fine. Yes, I'm going to get some sleep because I've got a long drive and a trip tomorrow. So I shall see you all very soon. I won't do that soon. Soonish. We'll get this printer finally printing something awesome. Thank you very much and goodbye.